Okay, so continuing to problem 9. In this problem, we have an optimization problem where we're trying to minimize some quantity. So typically in these problems, we're presented with two equations. So one equation in this problem is the volume formula, and the other equation that we need is the surface area formula. So so in an optimization problem, one is going to be the objective function and the other is going to be the constraint equation, right? So what quantity are we trying to calculate? So we're trying to minimize the amount of material used, which is represented by the surface area, right? So the quantity we're trying to calculate tells us the objective. So in this case, it's going to be the surface area. So that's the objective, and then the constraint will be the other quantity, which in this case is going to be the volume. And the reason it's called the constraint is because typically some quantity presented in the problem tells us that quantity is fixed, right? So in this case, it says that the volume should be fixed to 22 cubic inches, right? So the volume is fixed to 22, so V is equal to 22. So just setting up the equation, you get 22 is equal to pi r squared times h. And so the fact that the constraint is fixed allows us to solve for one of the variables. In this case, it's not too difficult to solve for h just by dividing this part here, right? So you get 22 over pi r squared is equal to h. And what this allows us to do is to now take this equation and plug it into the objective function. So I take this and I plug it into h here. So let's write it out. Right, so now S is equal to 2 pi r squared plus 2 pi r times h, which is this quantity here. So 22 over pi r squared. And by doing this substitution using the constraint equation, we've now reduced the objective function to only have a single variable instead of two different variables. And then now we can do calculus. Okay, so let's simplify this. Right, so S is equal to 2 pi r squared plus, and then 2 times 22 is 44. And then you can see that the pi divided by pi cancels out, and then this is r divided by r squared, so one of the r's cancels out. So what do we have left over? So I've already calculated 2 times 22 is 44, and then I still have an r in the denominator. Okay, so instead of thinking of r as being in the denominator to calculate the derivative more easily, let's just think of this as r to the minus 1 power. Okay, so now I have to take the, okay, so we want to minimize, right? So that means I have to find the critical point, so we take the derivative. Right, so s prime, so this is just the power rule, right? So the 2 comes down, so it's 2 times 2 pi r to the first power, and then plus, and then here the negative 1 comes down, right? So negative 1 times 44 r, and then it's negative 1 minus 1. Right, so now let's simplify this. So 2 times 2 is 4, so 4 pi r, and then minus 1 times 44 is minus 44, and then negative 1 minus 1 is r to the minus 2 power. Okay, so let's further simplify this. So this is 4 pi r minus 44 over r squared. Okay, so to find the critical point, I now set this equation equal to 0 and then solve for r. Right, so let's add this term over. So you get 4 pi r equals 44 over r squared. And then we cross multiply, so the r squared multiplies. So you get 4 pi r cubed equals 44. And then finally I can solve for r, so r cubed is equal to 44 over 4 pi. And then I just take the cube root of both sides. So r is equal to, and then finally I can calculate this. So cube root, so the cube root is located in the math menu. So the cube root operation is this one, so 4. So I want to calculate 44 divided by, and I have to be careful here because 4 pi is entirely in the denominator, so I have to put that in parentheses. Okay, so I want to calculate the cube root of this thing, and I get 1.518. Okay, so that's the radius that finds the minimum, and so they want the dimension, so they probably want the other quantity, which is the height. So once I know r, I can calculate the height by plugging it back into this equation here, right? So h is equal to 22 over pi times r squared, so 1.518 squared. So what is h equal to? So let's calculate this. 22 divided by, and then in parentheses, so pi times 1.518 squared, then I have to close this parentheses. Okay, so I get h is 3.039. Okay, so this should minimize the surface area. Okay, so to try to verify our calculations here, right, so we can go back. What are we trying to minimize? We're trying to minimize this function here, right? So so I can check using the calculator. Right, so I'll just use x for r. So 2 times pi r, so again x instead of r, x squared plus 44x to the minus 1 power. So let's graph this. So it doesn't make sense for the radius to be negative, right? So let's just change the window from 0 to 10, or maybe 0 to 5. It's probably okay. So we want the minimum. You see it has a minimum around here. So let's calculate it. So I found maybe around here. Right now, maybe around here. Then I have to guess somewhere in the middle. And so you can see here x is equal to 1.518, which is exactly what we calculated One thing you have to be careful is the y value is the surface area and not the height. So you have to separately calculate the height this way. Okay.